the relational model. In this lesson, you'll discover the ultimate game changer in data management industry. One concept that made a massive impact, reshaping everything we know about data management. That concept is the relational model. Let me share a bit of the story behind this groundbreaking development. The year was 1970. Edgar F. Codd, a researcher at IBM, published a paper titled A Relational Model of Data for Large Shared Databanks. And let me tell you, this paper was a big deal. Before this, data was stored and processed in all sorts of complex and unconventional ways. But Codd's paper introduced a revolutionary approach called the relational model, which changed everything. Suddenly, companies around the world were saying, "Whoa, this is way better than what we're doing now," and quickly began adopting the relational model for their own data management. The relational model completely transformed how we think about organizing data, paving the way for the development of powerful relational database management systems. It's truly mind-blowing how one idea can have such a massive impact. Let me explain the relational model to you now. The relational model organizes data in tables with rows and columns, where each row represents an entity, and each column holds data related to that entity. It's based on set theory, which enables powerful relationships between multiple tables. Let's talk about the importance of storing data in tables. The main reason for organizing data in tables is to structure and organize it effectively. This approach enhances the efficiency of data access and simplifies data analysis. Think of it like a messy closet. If your clothes are scattered everywhere, finding what you need takes longer. But when everything is sorted, access becomes quick and easy. Key terms in relational model. I know you're probably eager to dive into SQL concepts and start working with your SQL editor to reach your big career goals. And I totally get that. If you really want to master SQL, it's essential to start with a solid foundation. This means getting a good grasp on the basics of the relational model. It might be tempting to skip over this and jump straight to more advanced topics. But trust me, if you stick with me and focus on these foundational concepts, you'll be amazed at how much easier it is to learn and truly understand SQL. I know you're ready to get started, so without further delay, let's dive right into the key terms of the relational model. Entity. This refers to anything you want to store data about. It could be a person, a product, a company, or anything else. Records. Records are the actual data or information associated with an entity. Tuple. A tuple is a single record within a relation. Null records. In a table, there are times when no value is available for a particular field or attribute, or the data is inappropriate. In such cases, null is entered to indicate the absence of a value. It's important to note that null is not equal to 0, as 0 has a defined value. Additionally, null is not even equal to another null. Each null is distinct and unique, even though it's represented the same way. Essentially, null conveys, "I don't know," or "the information is missing." Column. The total values for a particular attribute make up the column of that relation, or table. Attribute. In the relational model, an attribute is a piece of data that describes an entity. It's stored in a column within a table, where each row represents a unique entity with its specific set of attribute values. Keys. In a table, an attribute that helps uniquely identify a record is called a key. There may be thousands, if not millions, of records with similar names or data, so a key is essential for uniquely identifying each record. A key is essentially an attribute, or a group of attributes, that enables unique identification of other attributes within a table. Primary key. A primary key is a unique identifier for each row in a table. It helps us differentiate between rows, ensuring that each one is distinct from the others. Properties of primary key. A table can have one primary key only. Primary key columns cannot contain null values. The primary key columns must hold unique values for every record in the table. Understanding the primary key concept is crucial in relational database management systems as it ensures each record is uniquely identifiable. To understand the concept of primary key, let's take an example. Consider a table named DataSep Students. To uniquely identify each student, a primary key is needed. The student ID column could serve as this primary key, allowing each student record to be uniquely identified. Foreign key. A foreign key links two tables together by establishing a relationship between them. It essentially indicates that this row in Table A is related to another row in Table B. Let's take an example to understand the concept of foreign key. If we have another table that stores the data of courses created by DataSEP's team members, and the table is named as DataSEP's courses. This table has columns as course ID, course name, and course teacher. Now, in order to relate the first table, DataSEP students, with this table, DataSEP's courses, we need a link. This link is established with the help of a foreign key. Here in this example, the link is established with the help of foreign key course ID present in the first table, that is DataSEP students table, and the primary key course ID of the second table. Understanding how the primary key and foreign key establish relationships between tables is essential. This concept plays a significant role in relational databases. Once you grasp how relationships are created for a couple of tables, you'll find it easier to understand how these connections can be scaled across multiple tables within a larger system. For instance, a school database system may have multiple entities, each with its own table, and each table connected to others. The teachers table might be linked to the students table, which in turn relates to the subjects table. Additionally, the students table could be connected to an attendance table. When designing a database, it's crucial to account for all entities, creating tables with the appropriate attributes for each entity. When complete, this interconnected system forms a complex web of relationships, known as an entity relationship diagram. This entity relationship diagram visually represents the entities and the relationships between them, offering a clear blueprint of the database structure. Normalization. This is the process of organizing a database to minimize redundancy and dependency. Essentially, it helps keep data organized and avoids unnecessary duplication. These foundational terms provide the basis for understanding the key concepts in relational databases. I hope you feel comfortable with each of these terms. In the next lesson, we'll dive into data, data types, and metadata.